Dawn broke over the shattered fields of Kursk, July 5, 1943. The morning mist clung to the earth like a living ghost, muffling the growl of engines and the whispered prayers of men. Through that fog rolled the behemoths of Hitler's pride, the Tiger I heavy tanks, their 88mm guns poised like the claws of a mechanical beast. Their crews believed nothing could stop them. In their steel citadel, they felt invincible. The Tiger was more than a weapon. It was a symbol of German supremacy in armored warfare, a machine built on the creed of absolute dominance. As they advanced through wheat fields turned to ash, German commanders murmured that no enemy tank on Earth could challenge them, and certainly not the crude machines of the Americans. Across the front, intelligence officers from the Wehrmacht described the enemy's armor as inferior in every measurable sense. They mocked the thin-skinned Shermans that burned, Sozeley and the hasty American assembly lines that churned them out by the thousands. They trusted in German craftsmanship, in Krupp steel, precision optics from Zeiss, and the myth of mechanical perfection. Reports from the Eastern Front confirmed their arrogance. Soviet T-34s were being torn apart at 1,000 meters. The Tiger's thick 100 frontal armor shrugged off return fire. Its cannon could destroy anything the enemy fielded long before they even reached firing range. Or so the reports said, compiled proudly by the German Armaments Office. Yet deep inside American factories, a quiet defiance was brewing. Engineers in Detroit, Pennsylvania, and Illinois studied photographs of knocked-out Shermans and vowed to change the equation. They weren't guided by pride or myth. They were driven by mathematics, materials science, and a ferocious belief that innovation could outpace intimidation. At Chrysler's Detroit arsenal, draftsmen hunched over blueprints by night, sketching solutions that might level the playing field. Fettiger's armor was strong, yes, but its weight made it slow, thirsty, and fragile in terrain. The Americans saw an opening, one hidden behind layers of German confidence. In the spring of 1944, that confidence faced its first fracture. Allied reconnaissance over Europe began reporting the presence of Tigers in Normandy. The news sent tremors through every command post. To infantrymen who'd never seen one, the Tiger was a monster out of legend. Its gun could vaporize a Sherman before the crew even saw where the shot came from. Veterans whispered of the Black Cross and the echoing thunder of its main gun. But behind that fear, American engineers and tacticians were already crafting a counterstroke. They studied captured wrecks, dissecting gearboxes, suspensions, and turret rings. What they found wasn't divine perfection. It was complexity bordering on madness. Each Tiger required over 300,000 man-hours to build. Its overlapping road wheels jammed with mud and ice. Its fuel consumption strangled its mobility. German efficiency, they realized, was suffocating itself. The Tiger had been designed in a world where every bolt was hand-machined, every part fitted with surgical precision. The Americans came from a world of production lines and interchangeable components. They didn't need a masterpiece. They needed an army of machines that could fight, fail, and be replaced faster than the enemy could breathe. By mid-1944, the U.S. was producing over 2,000 Shermans a month, a number so staggering that even Hitler's generals refused to believe it when their intelligence officers reported it. They laughed it off as propaganda, their faith still anchored in the myth of the Tiger's invulnerability. When the Allies stormed Normandy on June 6, 1944, the Tiger made its grim debut against American troops. At Villers-Bocage, German ace Michael Wittmann destroyed a column of British Shermans in minutes. The footage, later analyzed by Allied intelligence, became a warning and a challenge. The Tiger was no rumor now. It was a nightmare given steel form. The Americans, fighting through bocage and hedgerow, soon learned that frontal assaults against Tigers were suicide. But they adapted, as they always did. Field manuals began circulating with orders to flank, to hit the monster in its side or rear. Air spotters coordinated with artillery and fighter bombers. Don't fight the Tiger head-on, one manual warned. Fight the man who fuels it. Inside German headquarters, generals still repeated the same line. No tank can beat the Tiger. It was both mantra and curse. They believed superiority in design equaled victory. But by autumn, those same generals began reading disturbing reports. Their prize Tigers were being destroyed not just by airstrikes, but by coordinated tank formations using speed and communication. American units, once derided as untrained and mechanical, were moving like a living network, radio-linked, flexible, and relentless. The myth of German mechanical invincibility began to crack. In one intercepted message, a German major admitted disbelief. "They move faster than we can think." The Americans had turned war into a process, a factory of destruction fueled by logistics and engineering. Every wrecked Sherman was studied. Every failure was re-engineered. Steel alloys improved, welds were reinforced, and transmissions were simplified for repair under fire. The U.S. Army's Ordnance Department collaborated with General Motors, Ford, and the Aberdeen Proving Ground to test new guns capable of piercing the Tiger's armor. The challenge wasn't only about power, it was about timing. The race between field innovation and battlefield annihilation had begun as American forces pushed through the hedgerows of France. They met the Tigers face to face. Soldiers watched rounds bounce harmlessly off the German tanks and felt the terror of helplessness. But air support roared above. P-47 Thunderbolts dove through cloud and smoke, their bombs slamming into the ground around the Tigers. Slowly, methodically, American combined arms doctrine, armor, infantry, artillery, and air, began to strangle the legend. Where German generals saw the Tiger as the ultimate individual weapon, American commanders viewed their entire war machine as one organism, behind the front. At plants like Fisher Tank Arsenal and Lima Locomotive Works, new prototypes were emerging, tougher, heavier, and more lethal. Engineers like Joseph Colby and Edward Green perfected mounting systems for the new 76 mm high-velocity gun, a weapon that could finally punch through Tiger armor at range. The old narrative that nothing could beat the Tiger was about to be tested. German tank crews, once smug in their confidence, would soon find themselves staring at unfamiliar silhouettes through their optics. In the coming months, American engineering would prove that no myth, no reputation, and no masterpiece of steel was immune to the fury of innovation. Men who once called the Tiger invincible were about to meet its reckoning, and the battlefield where that illusion would die was already forming beyond the fog of Normandy. The monster had ruled long enough. Now, something new was coming, built not on arrogance, but on understanding, and it would shatter everything the generals believed about war. The Tiger's growl still echoed through the French countryside in the summer of 1944, but its roar was beginning to falter. Beneath the myth of German invincibility, reality was catching up. The Allied advance after Normandy had revealed a truth the German high command had refused to face. Their so-called unbeatable weapon was being outmaneuvered, outproduced, and increasingly outthought. The Americans were not fighting the same war Germany had prepared for. They were fighting a war of numbers, of speed, of minds. And their answer to the Tiger's menace was already being forged in smoke, sweat, and sparks from the foundries of the American heartland. At the Detroit Tank Arsenal, engineers and metallurgists worked without pause under fluorescent lights that never dimmed. Chrysler's assembly halls echoed with the clang of rivets and the whine of cranes lifting hulls onto endless tracks of conveyor belts. Here, the next generation of American armor took form, the M4 A3E8. Nicknamed the Easy 8. It wasn't as thick-skinned as a Tiger, but it was faster, with a Ford GAA V8 engine that roared at 500 horsepower, pushing 26 tons of steel at 30 miles per hour. Its new 76 mm high-velocity cannon, refined at Aberdeen, was designed to punch through 100 mm of armor at over 1,000 yards, finally giving American crews a fighting chance. According to the U.S. Ordnance Department's field trials in 1944, the new gun could destroy a Tiger's side armor at combat ranges previously thought impossible. Every piece of this evolution was a victory of engineering over mythology. At General Motors' Fisher Body Division, workers retooled entire production lines to fit the new gun mounts. In Pennsylvania, Bethlehem Steel developed stronger alloys to reinforce armor without adding excess weight. The engineers weren't seeking perfection. They were seeking repeatable, reparable, battlefield practicality. They created tanks that could be built in hundreds, not dozens, and repaired with tools that fit any Sherman in the field. This modularity became the cornerstone of America's armored doctrine. As described in the Army's Field Maintenance Manual issued in August 1944, but a weapon, no matter how advanced, was only as good as the men who wielded it. The Americans were learning the art of adaptation in the crucible of fire. After every engagement, gunners filed handwritten reports on range effectiveness, penetration angles, and ammunition performance. At Camp Hood in Bovington, analysts dissected those reports and fed the findings directly back to the factories. The loop was alive, a living organism connecting frontline chaos to industrial intellect. The Germans had their Tigers. The Americans had a network. And that difference was about to redefine armored warfare. In September 1944, the two philosophies collided near the French town of Arracourt. The morning fog rolled low across the fields as the 4th Armored Division's Shermans took up defensive positions. Opposing them was the 111th Panzer Brigade, equipped with Panthers and a handful of Tigers. German commanders, confident in their machines, advanced headlong into what they believed was an inferior enemy. They had no idea that American forward observers were already tracking their movements through the mist, calling in coordinates over FM radios that hummed with precision. The radio, a simple, often overlooked piece of equipment, became the Americans' invisible edge, while Tiger crews relied on shouted commands and hand signals. U.S. tankers operated as a synchronized organism. Lieutenant Colonel Creighton Abrams, commanding the 37th Tank Battalion, used real-time coordination between tanks, artillery, and air units to turn the battlefield into a trap. As the first Tigers emerged through the fog, American gunners opened fire, targeting the flanks just as training dictated. One Tiger erupted in a plume of smoke as a 76 round pierced its side near the fuel tank. In less than 48 hours, over 80 German tanks were destroyed or abandoned, while the Americans lost fewer than 30. The official U.S. Army after-action report from Arracourt described the engagement as a demonstration of maneuver, communication, and fire control overwhelming superior armor. Inside those wrecked Tigers, the aura of invincibility was bleeding away. German crewmen later captured spoke of confusion and disbelief, how Shermans appeared from unexpected directions, how artillery fire rained within minutes of contact. One prisoner admitted, dramatized composite, "We could not understand how they always knew where we were." The truth was simple. American engineering had extended beyond steel. It had built a system where information traveled faster than armor could turn its turret. Even as the battles raged, innovation continued to evolve behind the front lines. The Ordnance Department, analyzing captured Tiger wrecks, discovered weaknesses in the transmission, housing, and turret traverse motors. Engineers at Rock Island Arsenal responded by modifying Sherman turrets to rotate faster, giving crews precious seconds to fire first. Meanwhile, new armor-piercing ammunition, the M93 HVAP, high-velocity armor-piercing round, was rushed to the field. Composed of tungsten cores sourced from South American mines under the Lend-Lease resource network, these rounds could pierce the Tiger's front armor under ideal conditions. A single crate of HVAP rounds arriving in the Ardennes could shift the balance of an entire skirmish. By late 1944, Germany's armored divisions were being strangled by scarcity. Each Tiger cost nearly $300,000 to build and demanded over 1,000 gallons of fuel for a single day's operation. Spare parts were rare. Field maintenance was nearly impossible. American supply trains, meanwhile, stretched for miles, fuel, ammunition, and spare tracks delivered by the Red Ball Express at a rate the Wehrmacht couldn't comprehend. The battlefield wasn't just being won by the better gun. It was being won by the better factory, the better system, and the better rhythm of war. When the Ardennes offensive began in December 1944, the Tigers returned for one final show of power. In the snow-choked forests of Belgium, they ambushed Allied convoys, their 88mm guns lighting the winter sky. But even here, American ingenuity held the line. In Bastogne, Sherman crews dug in among frozen ruins, coordinating fire with bazooka teams and P-47 dive bombers that screamed down from the clouds. The air-ground integration, born from months of battlefield learning, shredded German armor faster than the Tigers could advance. Reports from the U.S. First Army recorded destroyed Tigers with penetrations not just from tank fire, but from combined arms working in perfect orchestration. What had once been the mightiest predator of the battlefield was now prey to a machine of coordination. Back in Germany, in a bunker near Kassel, engineers of Henschel and Sohn reviewed loss reports and realized their masterpiece had been outclassed by the very thing they despised: simplicity. The Americans had weaponized efficiency, dramatized composite. One German technician reportedly muttered, "They have made war like an assembly line." He wasn't wrong. Every destroyed Tiger represented not just a tactical loss, but a strategic humiliation. Their engineering genius had built one magnificent tank. The Americans had built an entire armored ecosystem, WWII early 1945. As Allied columns thundered across the Rhine, the legend of the Tiger lay rusting in the mud of France and Belgium. American tankers, once fearful, now advanced with confidence. The phrase, "Tiger-proof," appeared in unit briefings, a testament not to arrogance, but to evolution. From Aberdeen's proving grounds to the icy forests of Bastogne, American engineering had rewritten the laws of armored combat. The Tiger's terror had been neutralized not by brute force, but by adaptation, by minds that refused to bow before myth. The Invincible tank had met its match, not in another beast of steel, but in the quiet hum of American industry, and in the steady hands of those who believed no machine, no matter how formidable, was beyond understanding. By the dawn of 1945, the myth of the Tiger was collapsing under the weight of its own legend. On the shattered roads of the Ruhr and the Rhine, once proud German tank crews abandoned their vehicles, not from cowardice, but from futility. They had been told the Tiger was indestructible, that it was the king of tanks, the embodiment of German superiority. Yet everywhere they looked, the blackened hulks of Tigers stood as silent gravestones of arrogance. In the fields of France, in the forests of Belgium, and on the frozen plains of Poland, the symbol of invincibility had been reduced to wreckage. American tankers, who had once whispered about the monster with dread, now passed them with calm professionalism. The balance of fear had reversed. The war had become an industrial hurricane. Where the Germans built one Tiger, America built 50 Shermans. Where German supply lines crawled, American convoys roared. Trucks, trains, and ships feeding the front with an unbroken stream of parts, fuel, and ammunition. The real weapon was not the tank itself, but the system behind it. Engineers, logisticians, and factory workers bound together in a web of production that no enemy could strangle. Henry Kaiser's shipyards launched Liberty ships faster than the Kriegsmarine could sink them, while Ford's Willow Run plant produced a bomber every hour. This was war turned scientific, industrial, and unstoppable. It wasn't beauty that won, it was volume, coordination, and relentless adaptation. Captured German officers during interrogations after the fall of Aachen admitted disbelief at the pace of American recovery. One colonel confessed that destroyed Allied tanks would reappear within days, repaired or replaced, while German armor shortages grew worse by the hour. The United States had achieved the impossible. It had made warfare modular. Every component of the American war machine could be rebuilt, replaced, or improved with astonishing speed. Engineers back home monitored battle reports, updated blueprints, and sent out revised parts catalogs to the front, ensuring that every tank, even under fire, evolved with the conflict. Meanwhile, the Tiger's legacy was devouring Germany from within. Each one consumed the resources to build multiple Panzer IVs or dozens of anti-tank guns. Fuel shortages turned their engines into statues. Crews sometimes detonated their own tanks rather than let them fall into Allied hands. On paper, the Tiger remained fearsome, a masterpiece of engineering. But on the battlefield, its perfection had become its flaw. When it broke down, it stayed down. When it ran dry, it became a bunker. The Germans had built a monument to technological pride. The Americans had built a system that worked. Yet even as the Tigers burned, respect for them endured among the men who fought them. American crews studied each destroyed hull and each shattered turret, learning lessons that would echo long after the war ended. Engineers at Aberdeen and Fort Knox collected captured Tigers for testing, analyzing every weld and gear. Their reports, once classified, revealed how much the enemy's engineering had influenced future designs. The post-war M26 Pershing, born from those studies, incorporated lessons from the Tiger's armor layout and gun stabilization systems. The Pershing's 90mm gun finally embodied everything American industry had learned: range, firepower, and reliability in one package. It was as if the ghost of the Tiger had been dissected, understood, and reassembled, this time in service of democracy rather than dictatorship. Psychologically, the Tiger had served as both a terror and a teacher. In 1943, it represented invincibility. By 1945, it represented the illusion of it. The Americans had discovered that fear itself could be engineered out of war through understanding and repetition. Training films showed crews how to flank, how to coordinate, and how to exploit the Tiger's weaknesses. Once the aura of the beast was gone, it became just another machine, a target, not a nightmare. The power of myth had been shattered by the power of knowledge. As Germany collapsed, the final Tigers fought not as conquerors, but as symbols of defiance. In the ruins of Berlin, a few scattered vehicles attempted to slow the Soviet advance, their engines coughing black smoke as shells tore the streets apart. No longer were they the hunters. They were relics of a dying regime that had mistaken craftsmanship for destiny. Nearby, Allied tank crews watched in grim silence. They respected the enemy's skill but understood what the Tiger truly represented: a refusal to adapt, a belief that brilliance alone could stop the tide. The war had proven otherwise. After the surrender, Allied investigators toured the assembly lines at Henschel and Nibelungenwerk. They found half-finished Tigers, rusting components, and machinery that had fallen silent under Allied bombing. Stacks of blueprints lay scattered, marked by engineers who once believed they were building the future. But the future was already elsewhere, in the jet engines being tested at Wright Field, in radar arrays humming over Europe, and in the endless rows of standardized machines ready to be shipped wherever freedom demanded. The Tiger's age had ended not with a bang, but with a mechanical sigh. Post-war analyses, conducted by both sides, revealed the final truth. German precision had reached its zenith, but it had no foundation to sustain it. American practicality, by contrast, could evolve endlessly. Out of the lessons of the Tiger came the doctrines that shaped the next century: mobility over mass, adaptability over armor, and systems over symbols. From the jungles of Korea to the deserts of Iraq, the echoes of that lesson lived on. When M1 Abrams tanks later dominated modern battlefields, their strength lay not in their thickness, O farmer, but in their integration: sensors, computers, logistics, the same principles first proven against the Tiger, yet amid victory. The human cost lingered. Thousands of young Americans had faced the Tiger's wrath at point-blank range. Many never returned. On both sides, tankers perished inside machines that became their coffins, steel shells containing courage and terror alike. Veterans would later describe the smell of burning fuel, the sound of cracking armor, and the shock of realization that no tank, however mighty, could protect a man from war itself. The engineers and workers who built these machines rarely saw that cost firsthand, yet their hands shaped history as surely as any general's orders. Their welds, their rivets, and their sleepless nights ensured that the Allies would never again be outmatched by arrogance disguised as innovation. In the end, the legend of the Tiger endured, but only as a warning. It proved that brilliance without adaptability is a dead end. The Americans had not built a prettier machine. They had built a smarter one. They had proven that engineering was not about worshiping steel, but mastering it. The Tiger was a monument to pride. The Sherman and the Pershing were monuments to progress. As the war's ashes settled and Europe rebuilt, one line emerged from an Allied engineer's notebook, a thought scrawled in pencil beneath a sketch of a broken Tiger gearbox. Dramatized: perfection is the slowest way to win a fast war. It was the final epitaph of the Tiger and the lasting creed of American engineering, that in the furnace of war, genius means nothing without the courage to change.